Hello, this is Jess Marino, and I'm going to be talking about the economic order quantity, the EOQ. I will show you how to calculate it, talk about some limitations to it, but also talk about the best ways you could use it to your advantage. What it does, what the economic order quantity is an order quantity. How many should you order at a time when you need something? It helps you to manage the trade-off between ordering a little bit of something a lot of the time or a lot of something a little bit at the time. In an extreme case, you could buy a day's worth every day of the year, or you could buy a year's worth once a year. Neither one of those seems to make sense for most companies. So what they do is they try to come up with a way that does make sense. This graph shows the cost to carry inventory, which is a function of the more you buy, the more you're going to have around between purchases. Therefore, you're going to have more inventory. So that costs you money. It costs you money for space, the people in the space, the interest on borrowing the money for that, or even the opportunity cost. If you had the cash, you could have spent it other ways. The order cost has to do with the time it takes buyers to do the negotiating and research, the cost to track it, to receive it, to put it away, etc. It all adds up. So if you look, here you can see that for a smallish order quantity, the inventory cost is kind of relatively low, but the order cost is high. You're ordering a little bit a lot of the time. The other extreme is your order costs are low because you're ordering a lot, but your inventory is high. Therefore, this looks unappealing, and so does this. The way the EOQ works, this formula that we'll talk about, is that when each of these costs is equal is when the sum of them is at a minimum. And that's what it's trying to calculate. How do I reach the point where these are equal, therefore the two of them together is a minimum? So you take this formula that says twice my annual demand times the cost to order, divided by the cost per unit to hold it, and then take the square root of that. It looks kind of complicated, but it's quite doable in Excel with this formula. But you could see in this example here, you've got annual demand of 4,000. It costs you 50 bucks every time you place an order, and it costs you $2.50 per unit to carry it in inventory. You put all those together, put them into this formula, you get 400. And you have, again, this graph. However, things don't really get bought in a continuous fashion like this. You place orders at various times in the year. So as an example, if we had our 4,000 units and we have our economic order quantity of 400, that works out really well because 4,000 units, 400 every time we buy, that's exactly 10 times we buy per year. So it's intuitive and it makes sense. You can also see that here your order cost and your holding costs are equal, and any other combination you have has a total cost that is greater than this cost where those two things are equal. Let me walk you through a few limitations to the EOQ, however. One of them is all of the things you are assuming. One of them is that you know your demand for the year. Most companies don't know what their demand is over the year. They guess, they forecast. So you could have a very nice, yes, I want 400 10 times a year because I'm going to sell 4,000, but maybe you're going to sell 5,000. And now all of a sudden that very clean 400 economic order quantity is 447, which you can't buy an even amount of times, so you get close to that 447 and you buy 455 11 times a year. Or your demand is lower than you thought. So instead of buying the 410 times a year, you're buying 333 9 times a year. So you started off thinking I needed 400 and you placed an order for 400 thinking you were optimizing, only to find out your demand changed, therefore your EOQ changed. Same thing can happen with the order cost. Order cost is an estimate to begin with. You really don't know exactly what it's going to cost you to order. Plus, no two orders are exactly the same. Sometimes it's very simple. You've got a catalog item that you just call somebody or place an order over the internet and it's ordered. Others might be very expensive, require long negotiating, travel, multiple bids, takes a lot of time, a lot of money. Those are two orders that are placed, but they're very different and they cost very different. But let's just say instead of $50 to place an order, it was $20 to place an order. Now your EOQ of 400 has become 253. Note this. Notice the relationship between the more expensive, we originally had a $50 order cost. The more expensive the order is, let's say it's $5,000 to place an order, just to be extreme. If we did that, we'd only place one order a year, because why would we want to spend $5,000 every time we're going to buy something? If in this example here, in the most extreme example, if it's $5,000 to place the order and we placed an order every day, we'd spend almost $2 million just placing orders. Obviously ridiculous, but it does make the point. The other point on this is if your holding cost per unit became less, say if it cost you a penny to hold the unit instead of $2.50, now you'd buy a ton, because you might as well minimize your order cost. If holding it's going to virtually cost nothing, you might as well buy a year's worth at one shot. Or if it cost you $100 to carry the unit, now it's worth it to you to order every week, because that's a lot of money. And if it's $10,000 a unit, you're going to buy it in theory, it would justify all the order cost, all the carry cost that it would save you. So that's really the kind of the best part of the EOQ is to show you the sensitivity of the cost factors. Because where it's really not that great is on the actual calculation itself being the end all and be all. That's because if you'll notice, this is an estimate, this is an estimate, this can be an estimate. How can this be so precise? Estimate, estimate, estimate can't equal precision. And it looks very precise. When you see a graph and a square root and all this stuff, it looks like this has to be the right number. However, if we look, what we really see is that when you take these two lines and you take the sum of them, this point here might be the minimum, but the difference to the left or to the right isn't that great. Look at the difference from perfection here. Even if all these assumptions were perfect, and this was exactly right, this is what we sold, that's how much it cost, that much of that cost. If we ordered 400, it costs us $1,000 total. But if we ordered 444, $6 different. 364, $5 different. It really doesn't matter that much when you start to look and see that this line is quite flat. A difference in 43% of the units equals 6% of the cost on the high side, and 23% of the units is 3% of the cost on the low side. So you could go from ordering 10 times a year at 400 to 7 times a year at 571 to 13 times at 308, and you're talking about $35 this way and $64 that way. It's virtually irrelevant where you are on this curve, considering these estimates and this closeness. The way you can leverage this is you find whatever works best for your supplier. Say your supplier sells in packs of 500, just buy 500, or 300, or even 600 or 200. As long as you're close enough that it's efficient for packaging, shipping, maybe it's a pallet's worth, a full box size, something that in truth, rather than takes costs as a given, finds a way to minimize the cost by working with your supplier to get a multiple that makes their ease of doing business a cost reduction that they can pass on to you. One final note on the EOQ is that if you do reach a point, because even if your annual demand were 4,000, it's probably not going to be exactly 1/52nd every week. There's Black Friday, there's Mother's Day, Father's Day, back to school, lots of different times of the year that create seasonality or cycles or just uneven demand. So you may want to order 400 at a time, but if you need 700, there's no way you're going to order 400. You've got to always cover your near-term demand during lead time. You can't let yourself run out just by blindly following an EOQ. So the EOQ is obviously not perfect. However, it is an excellent way to recognize the trade-off between carry cost and order cost, understand that they both need to be considered, and blend it with a very healthy dose of common sense.